Unit 4, Day 4 Notes. Today we're going to prove that triangles are congruent using the side, 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 angle, side, angle, angle, side, and hypotenuse leg theorems. Alright, the first theorem we're going to talk about is side, side, side. Side, side, side is when you have all three sides of one triangle congruent to three sides of the other triangle. So this is again side, 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 or SSS for short. The next one is side angle side, where you have two sides and an included angle, included meaning it's in between the two given sides. So two sides and an included angle of one triangle are congruent to the corresponding two sides and included angle of another. So in our example, our two sides are BA and BC, and you see angle B is in between those two sides. On the other triangle, it's FE and ED, where angle E is between. So that's what it means to be included. You're in between the two given sides. And then we have angle, side, angle, where you have two given angles with an included side. So notice the S is in the middle, so that means the side should be between the two given angles. So in our example, we have angle B and angle A, where side BA is between. On the other triangle, you have angle E with angle D with side ED in between. So again, included means in between. Now we have angle, side, angle. I'm sorry, angle, angle, side, where you have two given angles and one side, a side opposite the given angle. So now the side will not be in between, it's going to be opposite one of the angles. Opposite means across from. So we're on the ABC triangle, we're given angle A and angle B, and then we're given the side opposite angle A, BC. We could have been given the side AC, but we will not use it for if it's BA. So it has to be across, opposite of one of the given angles. And the last one is HL, which stands for hypotenuse leg. And you'll be given a hypotenuse in the leg of one right triangle congruent to the hypotenuse and leg of another triangle. Hypotenuse is always opposite the right angle. In other words, across from the right angle. The leg is either one of the other sides. Two ways you cannot prove triangles are congruent are by AAA and ASS. Those two are not going to prove that triangles are congruent. In other words, just because three angles are congruent does not mean the triangles are congruent. If you have one angle and two sides where the sides are across, they're not in between the angle, or the angle is not between the sides, it doesn't work. Some hidden information that you should know is helpful. A reflexive side, in other words, when two triangles share a side, that one side that they share will be a congruent side. So you can go ahead and mark a congruent tick mark if there's not one there. You should remember that vertical angles are congruent. The bow tie angles, they're always congruent. Again, you should not have to be told all the time. You should know that vertical angles are congruent. And then you got to remember the properties of parallel lines and the transversal. So this little arrow here means that those two lines are parallel. Since those two lines are parallel, then you have some alternate interior angles here. Here's one, and there's another. Those would be congruent. And then you have another pair of alternate interior that are also congruent. You have these two right here. So you got to remember those properties as well. So again, if you see that arrow, it is at parallel lines. If the arrow is not there, we will not assume that it's parallel, unless we're told in writing that it's parallel. So we're going to see if these triangles in the pictures are congruent. And then we're going to state the reason they're congruent. It'll be one of the 5 we mentioned before. Side, 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 angle, side, angle, angle, side, or hypotenuse leg. All right, number 1. We have one congruent side clearly marked and one angle clearly marked. And then it's also set up like a bow tie effect. So we know that these angles here are also congruent. So we have angle, angle, and a side opposite the angle. So yes, triangles are congruent. And they're congruent because of angle, angle, side. Meaning the two given angles and a side opposite the angle. All right. In this picture, those triangles are congruent because of side, side, side. You have all the 3 sides are congruent to the other 3 sides of the other triangle. On example 3, we have two angles clearly marked. You have the angles in the corners and these right angles. But you should notice that these 2 smaller triangles share a wall right here. So you have angle, angle, and a side opposite the angle. So they're congruent because of angle, angle, side. Number 4. We have 2 clearly marked angles with a side in between them. So whenever you have a side between, that's an included side. So yes, they are congruent because of angle, side, angle. Number 5, you have 2 sides clearly marked and 1 angle. 2 sides clearly marked and 1 angle. These triangles are not congruent because we just mentioned on the previous panel that side side angle is not possible, or angle side side, depending on how you look at how you read it. Not possible. On number 6, we have 2 clearly marked sides, but then you should notice both of the triangles share a side, so this side is also going to be congruent. So since three sides are congruent, the triangles are congruent because of side, side, side. Finish 7 through 12 and snap a photo of your work. Number 13 asks, what additional information is needed to prove the triangle WGD is congruent to triangle DRW by side, side, side? So currently we clearly see that one side in each triangle is marked. You have RW marked and you have DG marked. You also know that both triangles share WD, so that's another congruent side. So we have two congruent sides. We want to prove it congruent by side, side, side. So we need a third congruent side, which means we would need to know that the other two sides are congruent. So we already have WD and RW and GD. So we need to that segment WG is congruent to DR. And I was making sure I was putting it in the right order because, yes, order does matter. W corresponds with D, G corresponds with R. Order matters, ladies and gentlemen. On 14, they want to know what additional information is needed to prove that triangle FRW is congruent with BMQ by side angle side. So both of the sides are clearly marked, but in order to prove by side angle side, we're going to need an included angle in between the two given sides. So when I look at the two sides, FR and RW, the angle that would be in between them is angle R right here. When I look at the other triangle, the sides are QM and MB, so the side or the angle in between them would be M. So we would need to know that angle R is congruent to angle M in order to prove it congruent with side angle side. Please complete this one and snap a photo. And this concludes your notes for this lesson.